So you are getting ready to venture off into the world of antacid titration. Okay, so let's spell antacid first the right way. A-N-T-A-C-I-D-S. And antacid is just that. It's a anti-acid. Oh, well, antacid, you say? Well, that probably means that I've got maybe some extra acid that's left over in my tummy. So when I take an antacid, it reacts with the acid that's already in my stomach that I might have a little too much of, and it neutralizes that out. That's the purpose of an antacid, ladies and gentlemen. Okay, so basically what that means is that when I have an upset tummy, well, my acid content is very high in my stomach. So what happens is that I take an antacid. In a laboratory, we call this a base. So I give you a tablet and you chew it up. That is a solid base that you are eating. Or I give you liquid, like milk of magnesia, and you drink it. That is a base that you are drinking. And we know that an acid and a base react together. We found this out in our last course in CTC 111. The acid and the base react together to give me salt and water. Okay, so for instance, the acid in my stomach is hydrochloric acid. So if I take that hydrochloric acid and I react that with a base, like sodium hydroxide, well, a single replacement reaction happens. Not a single replacement, a double replacement reaction happens. The hydrogen and the sodium switch partners. They're swingers. So the H and the Na switch, giving me NaCl and not HCl. And it gives me HOH, and HOH rewritten is water, H2O. So this is what happens when you take a Tums, a Rolaids, drink milk of magnesia, whatever kind of pill or tablet or liquid that you drink when you get an upset stomach due to acid indigestion maybe. This is the chemistry that's going on inside of your stomach when you take that ailment or that medication. So in today's lab, what we're doing is that we are titrating an antacid. We want to know on the back of this bottle that I have purchased. So here's my antacid bottle. There's a label. And on this label, it gives me the number of milligrams of the base. They all use different bases. Rolaids, Tums, milk of magnesia, they all use different bases in their formulas, but it's some type of base that's there. And it's going to be my job today to figure out, is that label telling me the truth? So when I begin to titrate this sample, and I begin to do my calculations at the very end of this analysis, hopefully my number will be the number that is on that label. That way, Tums is not lying to us. Rolaids is not lying to us. And we call this process a label validation process. Okay? So label validation basically means just that. I am validating this label that's on this product that you have purchased. And this label tells me how many milligrams of active ingredient that I have. And I want to make sure that you are eating or drinking that amount of antacid that they have printed on the label. Because if you're not, the company is lying to you. And if the company lies to you, then we sue them, we win millions of dollars, and I can retire. And you can too. Okay, so that's what we're here to prove today. Label validation of an antacid. And we are going to do this through the process of titration. Okay, so titration setup. You're already familiar with this already. We are going to have a burette, and then this will taper off down here at the bottom. And this burette will have a titrant in it. What that titrant is right now, I don't know. We've not talked about the procedure. We're just giving you an overview. Below, we're going to have a flask, something to put my solution in, and it's going to be my job to figure out the concentration of this solution. That solution is probably going to be my antacid solution. But the titration is not going to be as simple as you think it's going to be. With the standardization of sodium hydroxide, you had sodium hydroxide in the burette, you titrated KHP in the flask, and when it turned pink, that is when you knew to stop. This titration is a little bit more complicated because this titration is going to be called a back titration. So we're going to have to talk about this process of back titration. What is that really? What does that mean? And why do we do it? So that's going to be part of this whole pre-lecture video series. If you don't get to watch the entire video series before you titrate, it's probably going to be perfectly okay because the process of the titration is the same as before. You titrate using a solution, and you're titrating a solution in your flask. You titrate until the color change happens. So the whole idea and concept of titration doesn't go away. So we need to talk about how this is going to be a little bit different. Okay, so if we take a look at your procedure in the lab book, number A, Part A says preparing your samples. Okay, so to prepare the samples, it says that you are going to make a 0.1 molarity HCl solution. All right. And it tells you how much of that to make. It says 400 milliliters is what you need to make. And pour 200 milliliters of DI water into a 600 ml beaker. And then it says in a hood, fill 25 mils of graduated cylinder from the storage bottle containing the more concentrated HCl to produce the level needed to produce the 400 mils of a 0.1 molar HCl. Basically what they're telling you is that they want you to make 400 milliliters of a 0.1 molarity hydrochloric acid solution. They want you to dilute this from a more stronger HCl concentration. Then the directions are going to say you also need to make a 0.1 molar NaOH solution, and you need 400 mils of that one as well. Okay, well, this is also a dilution. They want you to dilute from a stronger concentration of sodium hydroxide. And this is all part of Part A. All of Part A is going to be done for you. So when you take a look at these directions, what will happen is that we will supply you with the pre-made 0.1 molarity HCl. This is going to be made already. And we will also give you the 0.1 NaOH. This is going to be made already for you as well. So you do not have to make anything in Part A at all. This is something that we will make. We will put them in stock jugs up in the front of the lab, and this is what you will use for your experiment on that day. So you do not have to dilute anything. You do not have to make these solutions. They will already be done. Now in Part B is going to be titled Standardization. And they are standardizing the NaOH solution that you have made, or that we have made for you, And they're also going to standardize the hydrochloric acid solution that we have made for you as well. So again, just because we say that we're going to make a 0.1 molarity HCl or a zero point 0.1 molarity NaOH doesn't mean that we've made exactly 0.1. And that's the purpose of the standardization. The standardization is going to tell us exactly what those concentrations are supposed to be. The standardization of NaOH. This is exactly what you have done in a previous lab. So this is going to be done for you already. We are not going to make you standardize the sodium hydroxide. This is your typical KHP in a flask. The KHP in the flask will go from clear to pink, and when it goes to pink, that's when you kick in the calculations and you figure out how much NaOH is actually there in your liquid samples. You have not standardized hydrochloric acid though. So this is something that we want you to go through. We want you to learn how to standardize an acid. Not just NaOH, but an acid now. Something a little bit different. So in the lab directions, you are going to look at step number 8. And step number 8 is going to talk about this whole concept of putting hydrochloric acid in the burette, and then in the Erlenmeyer flask down below, it wants you to put your sodium hydroxide. You're going to be looking for when the endpoint changes color. And that endpoint is going to change color not like phenolphthalein. It's a completely different indicator. So in the next video, we're going to focus more on this standardization of hydrochloric. And this is where you're really going to start the lab, because this will be your first step before you titrate any of your antacids.